One of the ways that we can measure electricity is through voltage. And voltage is a measure of the difference in potential energy between two different parts of a circuit. So, for example, if we've got a circuit here with a light bulb and we measure the voltage before the current gets to the light bulb and then also after using a voltmeter, we can see, say for example, we've got 6 volts of electricity before it gets to the light bulb and 3 volts of electricity after. This voltmeter is going to measure the difference in potential energy between the two, and it's going to read 3 volts. What does that mean? It means that this light bulb is drawing 3 volts of electricity. So voltage is a measure of the difference in the potential between two different parts of a circuit. Another way we can think of electricity is that it's a fluid, because it's the flow of electrons. So if we're thinking about fluid, a nice way for us to think about it is like water and how water flows. So let's imagine we've got a reservoir full of water here, and all of this water is pushing down with gravity and it's flowing out here. So the amount of water we've got in here is our potential energy, or our voltage. And so it's pushing that water out pretty quickly and pretty hard because it's got all of this water, this head of pressure pushing down. And what happens when the water level drops down and it's only this amount of water? There's less pressure, there's less of a head of pressure pushing down. So the flow out here is going to decrease. So our voltage is now less. That means that there's less potential energy. So there's less flow out here, there's less push. So voltage is often described as the push. It's what pushes the electrons through the circuit. When electricity is being transported a long distance, it's stepped up to really high voltage to be able to push those electrons through the wires for such a long distance.